Welcome to my channel. My name is Inayati and today I'm going to talk about main characteristics of cars. The main characteristics of a car are so important that having these features are usually marked on the body of the car. In this video, I'm going to talk about 4 most important ones in brief and order of importance. They are Powerplant type, engine specifications, powertrain type, and trim levels. First of all, we go to Powerplant type. Here, Powerplant means the source that produces the power to make the car move. And if you go in the market to buy a car, you have a few options regarding this Powerplant type. But these options may vary in each state. But according to today and future US market, we have these options in 3 types: internal combustion engine, electric motor, and hybrid system. Each type has its own variety, but today we are going to talk about internal combustion engine, and electric motor and hybrid system will be discussed in the future. But in an engine, we need a fluid as a fuel to be combusted and produce the torque from the force that is applied on the crankshaft. And this torque is going to be delivered to powertrain and eventually to the tires that are interface of the vehicle on the road for negotiation. Here I have listed the fuels that can be used in internal combustion engines, and they are gasoline, diesel, biodiesel, alcohol, CNG, and LPG. From this list, gasoline or petrol in British is the fuel that is used more than others in automobiles and is the fuel type and powertrain type that I'm going to talk about in this video. With this assumption, we go to next characteristic, that is engine specifications. For a gasoline engine, there are many features and technical things to talk about, but there are specific features and technical things that are supposed to be demonstrated by all car manufacturers in car catalogs, and I've listed 4 of them for you here. And if you want to get familiar with all of these features and technical things, you can follow my videos and watch them in the future. These 4 features are number of cylinders and their layout, displacement, maximum torque and maximum power, and fuel consumption. First thing for an engine to be considered is number of cylinders and their layout. Because of technicalities, number of cylinders for an engine is mainly even, with exception of some models of 3 cylinders and a few cases of 5. Also, first choice for a car would be inline cylinder layout, but due to space considerations, V-type and recently W-type are also on the table for designers to choose. So as you can see, this feature is designer's challenge and not yours. But what is the point in knowing number of cylinders and their layout for your car's engine? I'll explain in the following. Next feature is displacement. Displacement is presented and expressed in liters and is defined as the aggregate volume of all pistons in cylinders that sweep during one revolution of crankshaft for a 4-stroke engine. Imagine a piston that is in its bottom dead center or lowest point of its travel. Now, crankshaft starts to rotate and piston moves up to the point that it starts to come down again. If you calculate this volume that this piston sweeps during this movement and multiply that into the number of cylinders, you have displacement of that engine, and sometimes this number or multiplied in 100 or 1000 is marked on the body of the cars, especially for the cars that have a model with 2 or more engines and displacement in the market. But this feature is also designers' concerns. But why these information are given in brochures or sometimes are marked on the body of the cars? Because these information are very important. Number of cylinders, the layout, displacement, and if the engine is turbo boosted or not boosted are the information that can give you a fairly true conception of the car's performance regarding power, torque, fuel consumption, and even engine sound, and many other features that may be important for you as a customer. Okay, let's go to next feature of a gasoline engine, that is maximum power and maximum torque. If you refer to a car catalog, you can find almost in all of them a graph like this that represent the amount of power and torque in relation to engine rotational speed that is given in revolutions per minute or RPM. Sometimes these graphs are summarized into this format and are presented to customers. But to understand these graphs and numbers, first you need to know some definitions. Definition of work, torque, power, and energy. Imagine yourself. You have some energy in your body that is reserved in your blood and cells, and you know them as calories. Now, if you use this energy to move an object, you apply a force to that object, and the result in technical language is the work that you have done. Also, work is defined as the amount of energy transferred or converted. Now, if you use this energy to turn something, you apply a torque to that object. And now imagine that you are trying to turn a crankshaft. If the torque that you are applying to this crankshaft is big enough to overcome its initial resistance, the crankshaft starts to rotate with a certain speed. And from here, you need to use your power to keep this movement and rotation. So crankshaft resistance is drawing power from your body and is defined as the rate of work or energy transferring or converting time, and is defined as work over time. Also, you can calculate energy that you use to turn that crankshaft during a period of time by multiplying the magnitude of power that you use into time duration. Now let's go to units. If we have force in Newton and distance and length of the lever in meters, so torque is in Newton meter and also work is in Newton meter. But torque is a vector quantity and work is a scalar quantity. A vector quantity has direction and magnitude, but a scalar quantity only has magnitude, and in this case we have another unit for work, that is joule, and 1 joule is 1 Newton meter. And as I said, power is work over time, so joule per second, and 1 joule per second is defined as 1 watt. And also we have another unit for power, and it's horsepower, and 1 horsepower is almost equal to 746 watt. And energy, according to definition, is power multiplied in time, so joule per second multiplied in second equals to joule. And also we have another unit for energy that all of you know, and is calorie, and 1 calorie is almost about 4 joules. Okay, now let's study a graph. To achieve a high torque, you need to use a lot of juice and a lot of air to produce a strong combustion. But you cannot produce maximum torque in low engine speeds, because in low engine speeds, engine tends to stall, but in a certain speed you can take engine under full load. But after that engine speed, the torque is going to come down because of some technicalities and air supply limitations. In this case, engineers try to make this line as flat as possible at maximum by playing with features like boost regulation, valve timing, fuel injection duration, and ignition strategies. Now we go to power. Power in theory is in direct relation to torque and RPM. So when torque is increasing, power is rising too. But when torque is coming down, power is not following, because as I said, power is in direct relation to RPM too, and RPM is increasing up to the point that inefficiency and reduction of torque is a bigger player and power is coming down too. To increase these numbers, you can use turbochargers and superchargers, and an engine with boosted air supply system and fuel consumption as a compromise has a better performance under load. This boost system can be designed by engine designer or by aftermarket suppliers, and they come in a package called boost control system. This boost control system is expensive relatively and takes its toll on engine's life, and also installing them by aftermarket shops needs ECU reprogramming that may affect emissions. In general, buying a car with a boosted engine imposes you with some extra bucks and some maintenance concerns that you do not want to face. But in some applications, it is inevitable, and also it is very exciting to drive and speed up a very strong boosted engine car. Okay. Fuel consumption. Fuel consumption is expressed in two ways: liters per 100 kilometers in a SI system and miles per gallon for UK and US system. Maybe I can say that this parameter is the most important thing in lower and middle class cars, and all parties have concerns about that: producer, consumer, and government. And many features of a car can affect these parameters like efficiency of powertrain, aerodynamic drag, weight of the car, rolling resistance and inflation pressure of tires, efficiency of suspension system, and even accessories like air conditioning system, and even your driving habits can affect fuel consumption. But most important thing in this field is efficiency of power plant or engine. As a nice and modern gasoline engine has the thermal efficiency of about 35%, and a demand for a better and more efficient one always exists. And if I want to wrap it up nicely, I can say that there are 2 points regarding fuel consumption. First, you can compare the fuel consumption of your target car with its rivals if this parameter is important for you, and also the rates and numbers that are presented by car manufacturers are the rates and numbers that are obtained in laboratory conditions under certain loads of a dynamometer, and you may do not meet these rates and numbers even in highway driving conditions. Okay, after power plant type and engine specifications, we go to powertrain type. Here I have drawn all types of the powertrains that can be used on almost all automobiles, and they are front-wheel drive, rear-wheel drive, all-wheel drive, and four-wheel drive. That four-wheel drive itself is divided in two types, full-time and part-time four-wheel drive system. But if you look at the cars around you, you can find out that the most common type is this one. Front-wheel drive system is very suitable for city and highway driving and also for commuting. And for those who are looking for a car with fuel efficiency, this one is recommended one. And power transition in this system is very straight. After engine, we have transaxle and then driving shafts and wheels and tires. And since the weight of engine and powertrain is on the driving wheels, so power loss is less and fuel efficiency is high. On the other hand, we have this powertrain design that power needs to travel a longer distance in comparison to front-wheel drive system. But there's another design for this system that they have moved engine and transaxle to the rear of the vehicle and moved trunk space to the front as a compromise, and this space is used as a crumple zone for safety of passenger and driver in the case of frontal collision. But if this configuration is used for this design, power needs to travel from engine to the transmission and then to the propeller shaft and differential and finally axle shafts and wheels and tires. And this design is mostly used on trucks, but also those high performance cars that are bragging about their 0 to 60 acceleration time usually use this powertrain design. Shifting the weight to the rear wheels in uphill driving conditions makes this powertrain design desirable in many cases. But the space that occupied by transmission and propeller shaft is a challenge for designers, and also unbalanced rotation and vibration can bother occupants. The two other designs for powertrains are usually used on SUVs and off-road vehicles, but having these features are so important for both seller and buyer that usually are marked on the body of the cars. But what is the difference between all-wheel drive and four-wheel drive system for a car with four wheels? The difference resides in a component called transfer case. I'll explain in the following. Early all-wheel drive systems were also called four-wheel drive cars, and they used simple and open center differential to distribute power between rear wheels and front wheels. But soon demand for better and more efficient one got the engineers to make limited slip differentials. These limited systems make a restriction for rotation of drive wheels when or after they start to rotate without road traction and free spinning. But further development made the path for emergence of differential locks and also transfer cases that make it possible for driver to select for high and for low speed driving and mode. These systems are not very efficient and are suitable for off-road driving, and if you use them on pavement and highway driving, maintenance costs rise and powertrains wears more. Okay, up to now we have introduced traditional all-wheel drive and full-time four-wheel drive system, and let me clear for you again that the only difference between these two designs is that in full-time four-wheel drive system we have a transfer case that make it possible for us to go into for low speed driving, but in traditional all-wheel drive system we do not have any option for low speed driving and mode. Also in the market there is another design for four-wheel driving that is part-time four-wheel drive system. And this system is a little more complicated in the way that engagement works in transfer case, and we usually drive this system in two-wheel drive mode, but there is a button or shift stick for driver to go into four-wheel drive in high speed or low speed mode. Traditional part-time four-wheel drive systems were using mechanical means and gears and chains to go and select modes and speeds. But modern designs have been affected by drive-by-wire technology, and even names have changed. These systems may be called intelligent all-wheel drive, active all-wheel drive, real-time four-wheel drive, and other names that imply that they are smart cars. In fact, these designs are two-wheel drive systems that go into all-wheel drive mode on demand, and the call is on computer or computers, as these systems use function of other modules and computers like a stability control system to work out their job. In the world, there is a severe competition in this field. For example, GM engineers in 3 different companies are working shoulder to shoulder to not lose appeal for their all-wheel drive systems. In this case, Mercedes-Benz calls its all-wheel drive system Formatic, Audi uses Quattro name for the cars that have all new all-wheel drive system installed on them, and BMW uses X-Drive to present its all-wheel drive system that introduced around 2003. I will explain its system and its function in future, but something that I want to clear for you here is that designing, making, testing, approving, and developing these systems are very costly, and you as an owner need to know that repairing these systems out of warranty would be very costly for you. Okay, last thing that I want to talk about today is trim level. What is a car trim level and why it is important, and what is the difference between different trim levels? The answer to the last question is that different trim levels match different tastes. When a company offers a car with a specific body style into the market, it is desirable for them that their product be pleasant for the eye of everyone, and they, based on their market experience, put some specific features into that base model, and these specific features give that car a specific taste that is its trim level, and they assign a name to that trim level and publish these names and features in their catalogs and websites. Like many other things, there is no standard names and defined designations for these trim levels, and they are a letter or a few letters like L, SL, LX, or a word like Night, Premium, Limited, or any other nice word that the head of the company thinks is beautiful. The features that they play with to make different trim levels are features related to interior, exterior, safety system, driving assistance systems, and even powertrain. And sometimes a car with 2 different trim levels results in 2 very different cars with 2 very distinct prices. And if you have a car that you want to know its trim level, you can use its vehicle identification number and go to manufacturer website and decode that, and trim level is a part of that. And if you want to know more about VIN, you can go to part 565 of title 49, and there's a lot of information about this VIN. But if you are buying your car from car manufacturer, you can order some options on your car, and some companies are offering customers a package of options on their product. Also, you can select a base model and go to companies that offer aftermarket services and customize your car. Finally, it's up to you and your options available in your estate. But I think the most important thing when buying a car is power of your pocket and your mindset. I hope that this video was useful and informative for you and worth the precious time that you spent for watching that. Please subscribe to my channel if you like, and press the bell icon to be notified if I have a new video on my channel. Bye.